Okay, now in this video I'm going to show you how I took an old 9N tractor that I dug out of the field and converted it to electric. Now I use this tractor because I had it, and ever since it went through the ice on the pond it never ran well anyway. It's a small tractor, very common, so good for parts, and simple. It's also fun to drive. But it has some serious drawbacks. The main one being that it does not have live power. The rear lifter arms won't raise unless the tractor is moving. That's a real pain for snow blowing, rotor tilling, or cutting grass. Also, the reverse speed ratio is too fast relative to the PTO speed. Also, no good for blowing snow. But for some things, like pushing snow, it works just fine. I've also used this tractor on a PTO-driven hydraulic log splitter, on a brush chipper, and of course for just pulling things around. The PTO works fine with the tractor in neutral. Just rev up the throttle to wherever you want it. To start the conversion, the tractor needs to be stripped of the engine and all supporting components like the radiator. Most tractors use the engine as the front part of the chassis, so you need to build a new chassis that will bolt onto the transmission housing and also support the front wheel assembly. You need to be able to mount the engine, the battery pan, and the controller without interfering with the steering. Don't worry about accommodating the original hood. You'll likely need to build a new one. Now this is an outline of a typical tractor drivetrain. Note the power goes from the gas or diesel engine through the clutch to the transmission. Next, we will see how this changes for an electric tractor. The power comes from an electric motor. In this project, I eliminated the clutch and had the power go directly from the motor through an adapter coupler that my local machine shop made up directly to the transmission. No clutch. This made for a simpler construction. I control speed by choice of gears and throttle. I wouldn't do this again. Next time, I'll retain the clutch. Next, we see a bit more detail of the electrical components. First, the motor. This is a 50 horsepower, 96 volt motor. Motors usually come paired with a compatible controller. These are the heart of your electrical conversion and usually represent the major cost. Together, these two items cost about $5,500 US. Next, the batteries. You get better energy density with a 6 volt golf cart battery, but I needed 96 volts, and with limited space, I went for 8 12 volt batteries, once again rated for deep discharge. Here's the coupler. It fits onto the shaft of the motor at one end, and it needs to be splined at the other end to fit the transmission. The main fuse and kill switch are important safety components. The kill switch is mounted in a readily accessible place on the dashboard. These gauges show the RPM and the state of charge of the batteries. I've never taken the batteries below 80%, and I've pushed snow for 2 hours and split wood for 10 hours. Here we are charging up the batteries. I use 240 volt twist connectors to ensure proper polarity and a good connection. As I said, you'll likely have to make your own hood, which is fun in a way. You can do whatever you want. This one is hinged at the front and allows easy access to the batteries for maintenance and for showing your friends what's under the hood. Well, that's about it for now. Let me know if you have any questions, and I'd especially like to know about your project. See you when my next electric tractor is up and running.